Good afternoon, everybody. My name is Mark Mason. I work for Nature's Reward Farms out of Salinas, California. I'm a farm manager for the company. I'm also a certified crop advisor and a pest control advisor for the company. My role within the company is I'm in charge of all the pesticides and the fertility, which includes the water inputs and the nitrogen fertilizer inputs, or all the fertilizer inputs for the ranch. A little bit about the company. We're a fourth generation family farm. We farm on about 6,000 land acres in Salinas Valley, and it's two crops. So that's about 12,000. We do like 2.1 crops, so it's a little over 12,000 crop acres. And it's year-round production in the two different regions, which would be Salinas Valley, California, and then also Yuma, Arizona region. We are vertically integrated, so we've got our farming department as well as our harvest, our sales and marketing. We also have within the farm, we have a fertility department for the crops, and then also we've got our pest control department. The crops that we grow lettuce, broccoli, cauliflower, celery, strawberries, and then we have minor crops that we grow like endive, escarole, kale, some sprouts, some Swiss chard. Um, so just a real quick um, background of Salinas Valley. So the lettuce production in Salinas Valley is a planting from mid-December to mid-August with a harvest of mid-March to the end of October. Depending on when you plant, it's anywhere from a 65-day head lettuce crop to 120 days. And then when production is not during this time frame, it's in the Arizona area. According to the Monterey County Crop Report from 2018, which is the most recent, this is a $1.2 billion production value for lettuce. And this includes head lettuce, leaf lettuce, romaine, mixed lettuce, not baby green lettuce, just the commodity type lettuces. And then the number two crop would be broccoli for 2018. It's probably a similar trend. That lettuce is still number one. So as we look at our sustainability plan, there's a couple things that drive what we're doing as far as this sustainability. There's the county, regional, and state and federal regulations that they require upon us as growers. And there are the retail outlets. So the buyers ask for certain things to do on the ranch, possibly, or they may ask for certain things for us not to do. Activities they may ask us not to do may be certain pesticides they don't want us to use. Um, and then, the third thing here is part of our sustainability is, we're doing a lot of stuff on our own. So we try to take care of the ground and take care of the water. And so we're being proactive on the groundwater, trying to take care of the groundwater. All of the irrigation that we have in Salinas Valley is well water, so it's all pumped. Um, we're trying to take care of the natural resources as well as think ahead. What's going to be required of the regulators or the retail outlets in 5 years from now, 10 years from now, 20 years from now, and trying to adopt maybe some of those practices ahead of schedule. So non-production, just real quick, these are just some of the things that we've attacked that um, are part of a sustainability program. Solar panels, paperless farming. So, we're using tablets instead of, electronic tablets instead of clipboards with schedules and, there's no timesheets. It's all Pet Tiger as a program for timesheets. electronic program, variable drive irrigation wells to try to reduce PG&E power. We've fenced the Salinas River to prevent trash from blowing into the river. The river drains into the Pacific Ocean, so we get a lot of trash coming from Highway 101. So we have fenced where our ranch borders the rivers. Huge recycling program of drip tape, plastic mulch, which we use for our strawberries. A huge recycling program of all of our pesticide containers and harvest or pesticide cardboard boxes and harvest cardboard, and then as well as our pesticide plastic containers. So in our sustainability plan, there's a couple pesticides that are targets that we're trying to reduce. We're definitely trying to reduce all pesticides, but there's some, and neonics and pyrethroids are kind of the poster child of products that need to be reduced. So one way that we're doing this is we're using smart spray technology. So when the lettuce is small, the sprayer comes through, it only sprays what it sees. So there's a huge savings in products applied at this point. Grassed waterways. So we try to grass the waterways that carry storm water or possible tailwater. And a lot of times that tailwater may have some of these pesticides in it. And so the grassed waterways are there to help use kind of as filter strips to filter out some of these pesticides to prevent them from going into a discharge point, which will eventually end up possibly to the Salinas River and into the ocean. And then our pollinator strategy. So, we've encouraged vegetation where we can in non-farm areas, non-crop areas, I guess I should say. And then also, production or spraying at night. So when we go out and spray, we try to do most, if not all, of our spraying is done in the evenings. This is also to help with avoiding non-target drift from wind. Salinas can get windy, so again, we spray at night for that reason also. Nitrogen use efficiency, as the crops get uh, ready for fertilizer, we will go out and pull a soil sample and verify that they need fertilizer. So we run it through a computer program called Crop Manage, which was developed by Michael Kahn, University of California. We will put the soil sample results from a quick test into the Crop Manage system, makes a recommendation, and we take that recommendation as a tool. We can use the number that it's given us, or we can change it as we see fit as managers. That's been a huge part of our lettuce production in the last 5 years, I would say. High carbon compost. The idea here is that we put on high carbon compost in the fall, and as the rains come, so it'll be high carbon compost in the fall after, say a lettuce crop has been harvested. And the idea here is that when the rains come, the carbon has bonded with the nitrogen, and when it rains, it's not leached. And then in the spring, when we're ready to plant, this nitrogen becomes available. Number 3 here will be a smart side dress of fertilizer. So it's the same technology as the smart spray. And, this is still in development, but the idea here is that we go, instead of making a line of fertilizer, we put the machine in there, and whenever it sees we set the parameters of, when you see a lettuce plant, we want to fertilize, 2 inches on each side of that plant. And so then you're going through and you're smart side dressing. And then to water use efficiency, We are again back to crop manage, using crop manage for irrigation recommendations. We're using it as a tool to help manage our irrigation scheduling. It uses ET to help make these recommendations, and then we're also using the Open ET, which will help us determine how much water is needed to just replace what the plant is using. So the ET is just the minimum that it takes to produce the crop. We definitely use water more than the ET in certain situations, whether it's a leaching or soil type, but we're using this ET as the starting point. And then buried drip tape for lettuce germination. That way we avoid wind patterns from the sprinklers. And when we've got wind patterns, we tend to use a lot more water than necessary. So the wind blows constantly a lot of times in the area, so it's hard to avoid these wind patterns. And then crop uniformity. This is I see uniformity and high yields as a way to make us more sustainable. I mean, it makes sense to me that as your yield and your uniformity increases, and some of these inputs maybe stay the same, you've got less less natural resources, I guess you could say, per unit harvested. So that's going to be on this next slide here. So as we get more uniform and higher yields, we have, I'm going to call it a fixed input per unit harvested. So if we can get more boxes off the same acre with, every time we run a tractor through, right, it's the same amount of fuel per acre. And water may change a little bit. Fertilizer may change a little bit as you get these higher yields, or pesticides aren't going to change, right? It's just the same amount per acre, unless you're talking the smart spray. So I think all of these fixed inputs kind of are reduced per unit as we get our crops more uniform and higher yielding. So, to finish off, as thinking for the future on uniformity, mechanical harvest, and it's going to be destructive harvest, in my opinion. Uniformity is going to be the key, and that's going to be what we need, as well as the plant structure is going to need to be built to accommodate these harvesters that are going to come in. High-rise broccoli is a good example. There's some iceberg lettuce that may sit up 2-3 inches off the ground. Those are going to be, I think, as we get into mechanical harvest, are what we need, and then it needs to be uniform, as it's going to be destructive. As you get more uniform, there's some harvest models developed by some drone companies that work pretty well, but uniformity is going to be key on making these work. And then as you get more uniform, then you've got less food loss. So that's important also. So and again, the last point here is going to be that as yields increase and the uniformity is there, it fits into our sustainability goal. So with that, I'll wrap it up. I think I'm pretty close to on time, and thank you. I'll be available for questions. Thanks.